Hello, friends. In my mind, I have this beautiful, beautiful thing. I want to build a programming language. Ooh, no good. Well, let's do something simple. We'll do very conventional, straight-lined, single-family home. How does it turn out? Ooh, not good. Maybe I should go even simpler. I'll just build a NPM library, very small JavaScript library. Can I do that? I wonder, my website's on AWS. I wonder if it, oh no. It's strange to me how computers are, like, in some sense, the most deterministic things that humankind has ever made. And yet, if you type in frustration on Google, you get pictures of people with computers. If you type in peaceful, you get pictures of nature, right? Very strange. I love this Knuth quote. We are engineering things, silicon, at the nanometer scale. And like, literally I tried it backstage. Zoom takes 10 seconds to open up on my laptop. Just the login screen. That's bananas. I'm not a fan of that. So, today, I'm here to talk to you about some of Christopher Alexander's stuff. And I actually had to rewrite a lot of my talk because this is the smartest audience I think I've ever encountered. And talking to all of you nice folk before the conference, I realized that I was saying things that you guys already knew. And so, I am not here for solutions. I'm here to confuse you. I'm here to ask some good questions. And hopefully, that'll be something good to leave you with. Before I begin, though, I need some volunteers. My friend here, if I am speaking too fast, can you just raise your hand and get my attention, and I will slow down? Yep. You there. When I look really cool, can you take a picture and send it to me on Slack? So I can send it to my mom? And you, my friend here. If I say something really dumb, just raise 2 hands. All right? PHP. The frustration engines, computers. I got tired of working for clients, so I now channel my frustration in one direction, trying to keep things out of the landfill. Replenish, great company, love working with them. What we kind of do at this company is stadiums produce a lot of cans, as you can imagine. Stadiums, theaters, things like that. All those cans need to get to recycling facilities. And the recycling facilities have things that need to get somewhere else. And so we have apps and software that facilitates this whole process. I see lots of confused faces. Yes, I'm American. The government doesn't do this for us. They should, but they don't. We have to rely on Silicon Valley. One of the cool things about our software is you can see everything travel. Today I'm going to talk to you about my experience building stuff at this. The recycling centers, they have stuff, they click the app, and a truck comes to go take it somewhere else. Request a pickup button. So, came to the company, and this is my first idea of how I would build something like this. Basic table, you think that you have to start somewhere, right? And this is, maybe what the data would look like. And this process feels, I do woodworking, and I use these old, weird tools. And when you get one of these hand planes, the blade doesn't actually quite fit from the manufacturer. You have to take it out, put some charcoal from a pencil on it, and you put it back in, and you take it back out, and if there's charcoal there, it doesn't fit right. So you have to shave it away, like that, so that it's completely level. And if you shave too much away, then it's wiggly and it's no good. So it's a long process of trying to get this thing to fit. In the math world, you call this gradient descent. You have this fitness function, you have to test it out. And you can imagine in the real world with software, this could be very slow. Wouldn't it be nice if we just had equations? If we could just model things symbolically, represent them, so that we didn't have to try them out in the real world. If you read this book, I highly recommend it, you will realize that that is a little bit problematic. See, a lot of things cannot just be theorized and then put into existence, because the real world is complicated. And there's this asymmetry, there's this difference between the size of things that can go wrong, misfit, and the precise actual model that is real. You'll very rarely find that you can find a nice, tidy little equation to take care of all of your problems. It's generally you have to put the charcoal on, try something out, and then shave away the things that don't that don't go well. Here's an example. One of these is Wolfram's Rule 30. There's a very tidy equation for it. The other one I use ChatGPT to make, and I can guarantee you there is not a tidy equation. Actually, I can't guarantee that. I can't guarantee anything. And there it is, right? Like, I'm suspicious that the other one has a more complicated equation. So, back to my business problem. I've modeled something. I go to the business folks, and they start telling me things that are going wrong in my mental model immediately, right? I had bales in there, but not everything's baled. We do different materials. We do electronics. We do plastic, right? They all have different little things. And the accounts have different locations. There are different facilities under each of these accounts. So got some things wrong. Another part of the optimization process is this thing called annealing. Annealing is what they do with metals, and you have the temperature up, and you turn the temperature down, and you end up in all the molecules rest in the exact right place you want because you've slowly turned your temperature down. And the design process version of this is I like try to keep a whole bunch of different separate things in my mind, and I'm testing all of them out, and as I'm getting farther in the process, I turn the temperature down, like, okay, this one's starting to feel better and better and better. And what I end up with is something like this. It's a little bit improved, right? Like these little hypotheses I had all in parallel have cooled down and solidified into something that feels kind of nice. Much of the design process is this iteration on trying to get a high-dimensional, stable solution for high-dimensional forces. And this is a simple version. This is what it usually feels like, right? Like you're not just working in just this one nice plane. There's like all these knobs you don't understand. You are trying to ultimately fit a form you don't understand to a context that is ununderstandable to some extent. Not only that's fractal, right? This thing, it's got a fractal vibe. Think about like a column with pillars. If you get a little crack in there in the columns, then what ends up happening is capillary action. Soaks up the water. It gets cold. It freezes, cracks more, right? Over time, this thing starts crumbling. The building falls down. You have people that might be injured, hopefully not. If nobody repairs the building, other buildings in the area will lose their value, right? It's like this whole weird cascading fractal effect just from a small property of physics. And we feel that when we're working. For our ride share, right? We send people texts because people don't always have the app, right? So you send them a text. And you think about the thing in the URL, and you're like, oh, we have UUIDs, but we might want a little tidy short code. And in order to understand how that works, you have to understand a lot about how computers work. You have to understand, like, oh, maybe you can encode the UUID as bytes, and then you have some deterministic thing to get the short code. But then, what happens if that ID changes? You're like, oh, is that possible in the system? And you have this whole fractal thing that goes all the way down as you look into it. But it can also go up, right? Like, instead of worrying about the software level, I could just go lobby and say, we need all license plates to be the same. We need a standard, because I don't want to have to use a string. I want to be able to use something with a check that I can understand. There's too many license plates out there. Ooh, my lobbying will not go very far. The world is very, very complicated. So we have a high-dimensional problem space. We want a simple problem space. And remember what I told you, I have a lot of questions. I have 5 systems that do not work, and I will not provide any solutions. I am relying upon you guys to give me solutions afterwards. So let's go into these. Tradition. This hut is really cool. It has built-in scaffolding, so all repairs can be done without putting additional things up. It has like a ladder built in. And that's very important because in this region, there is no wood left over. The shape of it is pretty close to optimal for minimizing the amount of heat that goes in and also conserving the coolness inside, that particular shape. The rain comes down and it like goes into those ribs and makes the ribs a little bit deeper and also provides methods for being able to catch water. Right? Very, very good design. Christopher Alexander, this is his little discovery. That guy in the photo did not make this. This hut was optimized by tradition over generations, right? The culture itself acts as this gradient descent mechanism. But it only works if a few key characteristics are met. The same characteristics that make genetic algorithms work. You have to have some stable memory, right? That the memory has to work. You have to have a fitness function, and things can't be too chaotic. Otherwise, the fitness doesn't go in any direction. So the question is, can software benefit from tradition? Go-to considered harmful. I think Dijkstra wrote that. And pretty much overnight, go-to was gone. Null. Null is called the $30 million mistake, 100 million, something like that. And we're still using it. I think it's unclear whether or not the programming language, or the programming industry is learning from its own tradition. There's this thing called Chesterton's fence. The parable is that you buy a property, there's a fence there. You may want to build something, but before you remove it, you should probably check its purpose, right? Because there could be lions out there that are trying to get in. There could be a whole bunch of chickens on your property that you didn't know about that might be trying to get out. It's probably unwise to move it. And what's hard in software is like it's so new, right? They tell me there's this fence, but it's like computers are like 80 years old. That's it. In cars, 100. When I'm thinking about work and the Chesterton's fence, it's like, oh yeah, this thing is new. I can't trust that it was put there for any grand design or purpose. So it's like really hard sometimes in software to tell the Chesterton's fence from the Chesterton landfill, right? Processing speed has been going like this, but like latency, all of my experience with the computers has not been improving. smells like trash sometimes, right? And I can't distinguish between what's a fence and what's like trash, you know? That's on the grand scale. On the micro scale, what I didn't tell you about me coming into the company is there was somebody who did code before me. I had legacy code. I missed a whole bunch of stuff. For one, a very important thing that I missed when I made my own solution was quotes. We use third-party shipping providers, and we have to go ask them, but they take time to generate answers. So that's a whole giant thing that you have to make. You don't get instant quotes, right? I completely missed that. And that really, if I had looked for the fences better, I would have been able to prevent some problems. On the other hand, I removed 10,000 lines of code when I proposed my solution, right? And I think next month we'll be able to remove 1/5 of the code base because when I looked in there, I saw some assumptions that were no longer true, right? The product had changed, some libraries had improved and done things we couldn't before. So we ended up being able to remove 10,000 lines of code. That felt really good. So I don't know, it's this whole big mixture of fence and landfill that I'm still not sure how to distinguish. That's what it feels like sometimes. Software folks don't know how to build huts. In one of Christopher Alexander's books, he talks about the igloos, and when there's a leak in the igloo, it's pretty direct. Like you're doing your thing in the igloo, it starts leaking, and you can still think about something else. You can climb and you repair it, and there's not a whole model. You don't have to think about. But back in igloo school, what did they tell me to do in this situation? Right? You just do it because you've been doing it your whole life. This situation, right? If there's a leak in this building, you need to get an architect involved. You have to understand the concept of money because you have to have money to pay somebody to fix it, and maybe there's regulations involved if it's in a particular spot. You have to fix it in a specific way. Super complicated. And the reason it is complicated is because it was built with abstractions. That is like necessarily so. And the reason it is necessarily so is because when your only tradition is oral, your systems can only get so complicated. There's a limiting factor. It is abstractions that enable things to become complex. When you mismatch the physics, things happen with the mental model you have. Things can go awry and get complicated. I feel this way sometimes about you have your assembly code and then you have all these classes, right? It's like Roller Coaster Tycoon was made by one person in assembly. I think that was Roller Coaster Tycoon 2. Does anybody know? No. Or 1, I don't know. I don't know. But at the same time, I am unsure if we could support all of the wonderful software we have today without some higher level structures. So it's weird. I think sometimes I think that I'm architecting a city and I'm only playing SimCity, right? I have this beautiful SimCity working and all the people are healthy and happy, and then I go put it on production and it is not a good city at all. The people are very unhappy in the real world. Classic engineering problem. I don't think I'm the only person that feels this way. So, you might be saying, what if you just built igloos and then built blueprints for these igloos? Keep things simple and make simple abstractions. Doesn't work. The abstractions start diverging because the moment you have that separation, so that the people in the igloos can go, if somebody else is doing it, I can make my igloo twice as big because I'm just working for money, and you have some separation. And like, oh, now that I have money, I can put more stuff in my igloo. Once this loop is broken, you automatically start getting these like incentives that can separate. So, back to my problem. Where do I store this? Text file? Plain text? No database, just put it in a file. Not a good idea. Thank you. ORM? Oh. Object-oriented or functional? Depends. This is my goal, right? All of those things I just talked about, object-oriented, functional, they feel really small to me when I think about my goal working at this place, the software I'm making, is to keep things out of a landfill, right? Once I like re-engage that part of me, like the purpose of what I'm building, a lot of these questions, it's easy to remember that they're abstractions and distractions, right? A lot of you have probably heard of this book, A Pattern Language. I recommend very much. Christopher Alexander talked at OOPS Law 96, the big object-oriented programming conference, and he was a little bit, you can listen to the talk, but he seemed disappointed with how patterns actually turned out. It sounded to me like there's no real evidence that they did what he wanted to. And if you read his later work, what is it? The Nature of Order, something like that. Very, very good. Much longer, though. Patterns are just another level of abstraction. They might not do exactly what you want. So, let's get down to the facts. Science. One nice thing about science is it works regardless of whether or not you believe it, whether or not you trust it. It just works. And sometimes can simplify things. This is how people were charting all the stars and planets before the heliocentric model, before we knew that the sun was in. They have these things called epicycles. You know how annoying that math would be to do? Not very fun. And then it just turned into that. Bam. Much nicer. Another story in this vein that I really like is about Semmelweis. He's credited as the first physician to realize that washing hands is probably a good idea. The hospital he was in, people would be doing autopsies and then delivering babies, and autopsies and delivering babies, and that's not a good thing. And so he was the one that said, wash your hands, doctors. And they did not want to hear that because when you have spent a long time doing something, it's not fun to be told to do other things, right? They'll tell you, this is a craft, this is an art, it's not a science. Whenever I hear that, I think of good old Christopher Alexander, who I think was trying to say some of the same stuff, that we can be scientific about design. And I'm like, ooh, when I hear that, I'm like, ooh, am I being scientific about design? And I look back, no, my designs are not good. So how do you do science? Anybody can do science. You just have to be very specific about your questions. You have to make questions that somebody else can verify. That's it. That's like the whole thing. It's not hard. You just be specific. Some things I've started to be specific about that I really like. First one is dollars per kilowatt hour. This is If you want to compare whether to like build or buy, whether or not to allocate a team to do something, you can try to convert things, try to do a rough napkin math on dollars per kilowatt hour. And the key conversion is that humans use about 100 watts per day to live. This is 100-watt light bulb right here, guys. My mom would say that I'm like 30 watts, but 100 watts. Smiles per watt. I think we don't talk about how happy things make people. On my blog, I posted a whole bunch of consumption metrics for Netflix, for Spotify, all these things. Turns out that on average, people pay about $1 per hour of digital entertainment. And that's remained constant for like 10 years. Weird, right? $1 per hour of whatever that entertainment is. I'll skip a few of the other ones. I do like the time capsule test. You can play a little mind thought experiment. If all the documentation on this project disappeared, how long would it take somebody to figure out how this works? That's something that you can actually experiment with, but it's pretty impractical because it gets into the hundreds of years sometimes. We have to be careful about metrics because remember, this is a multi-dimensional thing, and if you just focus on one dimension, you end up messing everything up because you optimize for the wrong thing. So always beware of Goodhart's law. So back once again to my own personal problem. How can I be scientific about this? How can science help me make this a little bit better? One thing I have found that I think is scientific is type theory, right? Type theory gives you certain guarantees about your system. And if you are, a little bit methodical, then there's certain classes of errors that you just don't have to worry about. It doesn't turn your problem from 6D down to 1D, but 6D down to 5D, that's nice. There are certain things you just do not have to worry about. And there are certain costs in some situations up front that you have to pay. But overall, I have found that it is worth it. And I wish there were more science on this, because I go online to try to find, is functional programming, is there any evidence that it is better? And I haven't been able to find that evidence, right? It feels more like horoscopes sometimes. Programming languages, is there any really stellar proof that any of these languages matter? I haven't seen it. Maybe I'm just not reading enough. Again, if I am wrong here, please send me angry messages. I want to know. Sometimes all of this science feels a lot like the medical industry, where medical research is precise. It is science, right? It's a little bit fuzzier than physics though, because you're dealing with epidemiology, right? But this is a real fact about the world, right? That humans, high blood pressure ends up being not good for you. We can measure this statistically. We know based on the physics of your arteries and stuff, right? Pressure, right? Yeah, not good to have high blood pressure. A little tension. And why did I put this in here? Oh, if your doctor says no, medicine, it's all just opinions. There's no facts. If your doctor tells you that a blood pressure of 0 is debatably bad, if there's any room for argument, I encourage you to find a new doctor. But what's weird is that I don't see any of this same stuff in software. All I hear is it depends. I don't see any really, really hard lines anywhere, and that's weird to me. That this is the number of lines of code in the Linux kernel since 1991. I think this is the Linux kernel. And now it's at 30 million lines. It's bananas, right? Like that's a lot. Just a quick aside, how big should a program be? Is 30 million lines too big? Let's try using some science. Okay, this is Kolmogorov complexity. It states that the smallest a program can be is like the compression of it plus the compression algorithm glommed onto it. That's the smallest theoretical program it could be. So we do have a rough lower bound on things. And actually, you can do science at home. I have a little blog post, a little script you can put in any program, and it will give you a rough estimate of at least one type of lower bound of your program, right? So this is not some weird theory that like cannot be actually tried in the real world. You can do this science at home. Another place where you start seeing the science pop up is Project Euler and the Code Golf Stack Overflow. You start looking at these. This is a literal program that prints Hare Krishna a whole bunch of times in a certain pattern. I'm not joking, it's 22 bytes. This is where I found it. This is how it works. When you start seeing things like this, I also think, I think programs can be a lot smaller. And I don't know. Whether or not it's useful, I'm not sure. This guy, look up a ref term, R-E-F-T-E-R-M. This guy wrote a alternative to the Windows terminal and had pretty much feature parity, according to him, and runs like 10,000 times faster, right? It can stream, 10,000, 100,000, somewhere in there, more characters to the stream per second. And it's just one guy, in a few weeks, it's like 500 lines of code. And you compare that to like the whole Windows team that's been working on Windows Terminal for decades. It's strange. Something feels wrong there. It feels like there's a blood pressure problem to me. And it's weird that the science is not working here. Something's wrong with our science. I'll skip this, but no, I'm not going to skip it. It's good. It's so good. Will this work? I'm going to skip it. Look up Croquet, C-R-O-Q-U-E-T. Alan Kay made a whole operating system in 15 megabytes. And it can roughly do everything that a Windows computer can do. That's weird. Isn't that weird? Like, look at the demo. He's got like this whole like virtual reality thing going on. It's got like this AI thing where he draws a fish and the fish swims off. You draw it in 2D and then it like pops into. It's weird. It's weird that like I see some lower bounds here, and nobody's willing to say that 30 million lines might be a blood pressure problem. This is the average age over time. Been getting better. Medicine has been working, right? Sometimes it doesn't feel like that because you have all these like, you read the dietary research and you're like, oh, none of this seems correct. But overall, they're getting better. Hardware's getting better. I'm unsure if software's getting better. I'm unsure which parts of software are getting better because latency seems to be the same. Number of bugs seems to be the same. I don't know where the science is. And that might just be me. I might be just looking in the wrong spots or with the wrong communities. One other thing is that software, it seems like, might be contributing to some unhappiness, and that's very not good. That puts a little bit of urgency here. We have real-world side effects that teen suicide rates are going up. If we have anything to do with this, we should probably get on this fast. I tried reading the research, but like, I don't know, what's the ratio of industry people to academics? Very small. I can't read these research papers. They're not written for people like me. They're written for smart people. There's a paywall on almost all of them too. It's like, why is research require money? So if science doesn't work, maybe we should just rely on intuition. We have a 6D problem, and you are equipped, everybody is equipped with a very, very fast neural net. Neural nets are very good at high dimensions. All you need to do is to match. Sick your neural net on finding things that seem stable in high dimensions. Oh, predictable. Must be scientific. Otherwise, you can't share it really, right? It's just an opinion, not very useful. So you have your neural net working full speed to find things like this. Where do you find them? You end up finding them pretty much everywhere. Anything that feels living is necessarily one of these systems. It's living, stable, harmonious. It happens to be this cloud of words for this experience. Your pattern matcher has already glommed onto these experiences. This is the gist of Christopher Alexander's book, The Timeless Way of Living. You end up feeling alive when you interact with systems that feel alive. And you can recursively design systems that feel more or less alive. When I'm programming, it's weird. Some days, it feels like it's all the best parts of like a Zelda puzzle, where like, I feel so smart that I was able to figure out this thing, and I'm like, yes, I get that key, I don't know, whatever. Some days, it is misery, because I'm just like, in like Python, some Python package broke, and it took me 2 days to figure out to clear my entire machine. It's like, it's frustrating, right? Sometimes it feels living, and sometimes it feels dead. And like, everyone I talk to happens to have that same feeling sometimes. And it's weird because people tend to report the same feelings about the same things. And if you read Christopher Alexander's work, he makes a very good case that there's something objective there, that this is not just a matter of opinion, even though it is people's opinions, right? At a statistical level, you can measure, you can make predictions about people's opinions. That's fact. Facts about feelings. Another smell I have is documentation. Everyone here hates documentation? Yeah, okay. Everyone here hates documentation. It is a smell that something wasn't designed correctly to me. It is the best programs, you look at the API and you're like, oh, I got this. And you do it, and if something goes wrong, it tells you exactly what went wrong, and you're like, oh, and you just tweak it. But you don't have to like go learn to learn, right? Like there's not like a whole bunch of levels of indirection. It's like this natural feeling where you just interact with the things that are happening. Christopher Alexander has explained this as different forces that you need to be able to resolve, you yourself. People like being next to nice windows, but people also like to sit. If the chairs are not next to the light, you will be uncomfortable. And these forces kind of exist everywhere. For instance, I am wearing a jacket right now. I'm extremely hot, but I'm sweating a lot under here, and if I take it off, then I will be embarrassed. So these forces are colliding. See, very, very sweaty. These forces, when you look at them, they're also these like recursive over time. They get worse. So if you have a guest bedroom that let's say the window is not next to the chair, right? And there's no way to resolve those forces, then you won't go in there. If you don't go in there, then you will never know it needs to be cleaned. And if you don't know it needs to be cleaned, then you're gonna wanna go in there even less, because you're gonna be like, ooh, I haven't cleaned there. And then your friends come over, they're like, oh, we're in town. And you're like, oh, how about we come over? And you're like, oh, yes, you can stay in the guest bedroom. And then they stay in there and they say, we're not friends anymore. And then you have no friends because the chair was not next to the window. Same thing for legacy code, right? Oh, we'll refactor it at some point. And the longer it goes with your team avoiding that module in your code base, the worse it's going to be. And you're just going to keep on finding every excuse. And the problem's just going to get worse and worse until your company is bankrupt, right? Because you couldn't fix, at some point you can't fix that thing. My own heuristic is only refactor the things that you can't. Even if your system is stable, right? Your house has every chair next to the right window. Everything is precisely where it should be. Everybody's happy. Your house is vibrant. Doesn't mean that's not part of a dead system. Suburbs are a key of this. Everybody in the suburb might be happy, but suburbs have forces. They create forces that cannot be settled within people, right? Parents have to go to work, but they want to be with the children, right? That's a conflict. Children now has to go to school, but they don't want to because they want to go, learn what their parents do, right? Like, isn't it fun to go to work with your parents, right? But then, because of the structure, the parents and the children don't understand each other, and like the parents get home from work and they're tired, and the child doesn't understand what their parents do, and so nobody has a common ground, and the children misbehave because they have no respect, and the parents, and so on and so on. My one problem with intuition is that I hear a lot of people talk about elegance in software, and that always like scares me. I'm like, oh, elegance living, right? It can become this thing that is a false idol. In the same way that the Industrial Revolution of England, the main word everyone says, efficient. This must be efficient. And of course, it led to a lot of good things, but it also led to a lot of pollution and stuff that we are still dealing with, the pursuit of efficiency. I think sometimes the pursuit of elegance has the same thing. So you have to be very careful how you pursue living systems and try to get your perspective as large as possible. Last section is heuristics. A whole bunch of things that don't work, as I said before, but that I like. So I'm gonna impart some things that have worked for me. Let's go back to my original example. Remember, these are the structures for requesting pickups in our system. One thing that felt very alive that happened recently is the designer at our company kept on giving me Figma designs and the mock-ups, and I would create them, and you would go, this is trash. The corners are not the right thing, or the things are twisted, not responsive, like no good. And I'm like, the designer knows CSS. Why is the designer giving me Figma files for me to mess them up, right? Try to implement them. I was like, hey, do you want to just contribute to the code base directly? He's like, yeah, sounds great. He's like, but am I smart enough? I'm like, yeah, you're playing smart. Now he's just committing. That saves us both a lot of time and headaches. This is a pattern you will see all over the place. My first job, I sat next to the head of customer support, and he kept on asking me for things. I'm like, I invited him over for a weekend, taught him SQL, and he just started solving all the problems. Instead of saying, hey, we're having customers do this, he'll just be like, hey, your module over here is incorrectly adding stuff into this column. So much nicer of an experience for us. And he was happier too. Less frustration all around. You have to give people the tools to resolve those inner forces. That's a living system. Another thing that I like, Manasobu Fukuoka. He is famous for being anti-science, but also do-nothing agriculture. Right? He is able to grow 3 times the amount of produce per acre by doing literally nothing. His books are wild. It's a whole thing. Because nature does, know what it's doing, and sometimes we think we know better than nature, and we don't. One area I try to do nothing development is where I just kind of write code, and I write lots of it, and I just keep it in a single file. And it gets 2,000, 3,000 lines. No modules, no other files. Just I call it the Great Wall of Code. And some people don't like this. It's uncomfortable at first, but it's weird because all my coworkers, they see it and they're like, I'm not dealing with this. And then after literally 20 minutes, they're like, oh, I understand the entire thing because I didn't have to jump around from file to file. So in practice, it seems like it's working. I'm not sure what the limits are on that yet. If I was to be scientific about it, my guess, here's Taylor's conjecture. I think code bases, when you have a whole bunch of modules, right, things that point to each other, this is OOP or functional, right? This is just, you have things that look like a network, you're gonna get things that look like this. But if you keep things in a file where it's linear, it's more painful, and so you end up getting logarithmic. That's my conjecture. I think you could search that or do some statistical studies on GitHub, and my conjecture is that you'll find that. Here's another heuristic. Every system is characterized by the events that occur in it. My code base that I inherited was it took 2 hours to do the CI checks. That means that we only had 4 opportunities a day to be told that we were wrong. That is very slow. So one of the first things I did when I joined the company was I made it faster. It's now 2 minutes, 2 hours to 2 minutes. Huge difference, because the computers can tell me I'm wrong way faster now, and that's a huge benefit. Another thing I like, IKEA-oriented design. It's a heuristic I have. Make semi-disposable structures, right? IKEA furniture, it's not, you can do whatever you want with it. It's not like this grand master plan that is not, it's not an Eames chair, right? You feel comfortable doing what you want with it. If you need to cut it in half to fit your dimensions, good. So as soon as I feel like I've built this very grand thing, I start getting suspicious of it. It needs to feel like IKEA. One example of this was I realized that on the front end, when people were trying to get these pickups, they had to do lots of estimates, right? They would come back and be like, no, I don't want that. So I had to actually separate the estimate from the delivery. The pickup was not a shape that actually mattered at all. You have an estimate that is given to you, and if you like that estimate, you can go and request a delivery. Another cool thing, look up this Gossamer project. We have human-powered flight, and not really any science was necessary. The only reason these folks were able to fly was because they focused on attempts and making systems with duct tape and really cheap materials and just iterated. No groundbreaking science here. First people to ever fly by human power, and it was just a process difference. In my case, I kept things lean, and so was able to, I realized that, okay, you don't know, they give you a quote ID, these third-party providers sometimes, and it could be a very long time before, so I had to do a whole bunch of stuff, but it was nice because I could just throw things away, iterate quickly, because everything was made with duct tape anyway. One thing that's been very conspicuously missing from this is people request pickups, but lots of people request pickups, and those pickups might be near each other. I tried building that the first time around and did not work. I did not understand the problem enough. So I went to product, I said, hey, is it okay if we don't share trips? They're like, yeah, that's fine. And so now we have something that works, and we can grow a complex system out of a simple one. Feels like a much nicer experience for me, at least. Jigs, I said I do hand woodworking tools. In woodworking, you end up building a lot of the tools that you build with. Like you build your bench, and then you build things that do right angles and to repeat. And I don't see this in software enough. Like, people don't make things out of the things that they're making with. So I do a lot of SQL. I write lots of scripts in SQL. And it's not a very good experience, but it's a great experience. And it's hard to convey, but like, if you're doing lots of SQL, don't like put all of your eggs in like, I don't know, Java script or Python scripts because it's not SQL, and you'll get some like parity difference, right? Like, make tools out of the tools that you're making. There's these things called desire paths. That's another heuristic I have. If there's some force that keeps on happening in the company, this frequently happens with customer support. You keep on getting the same problems. Go fix those problems. That's some force that the universe is telling you is problematic, causing conflict. Also realized in my code that sometimes the trucks do not make it to their destination. It's very rare, but it happens. And the question is, do you add an edge case? Do you play by your own rules? That's something I haven't figured out yet, right? I could allow some weird zeros in there, but then that's a foot gun waiting to happen. So then you could add a very, very specific edge case column in the database, but then because it's rarely used, it's rarely tested. And so I haven't found any answers for this, but this is one I think about a lot. Protocols versus platforms. One other thing I like to think about a lot. If you are making something that is very proprietary and specific, sometimes it's easier to just think, what existing tools can I use? Because software has been around a while. And the protocols are quite nice sometimes. Anyway. I hear people walking back there. That was my talk.